Okay, so in this video, we're going to talk about the quadratic formula and how to use quadratic formula to solve quadratic equations. Starting with example 1, we're going to prove the quadratic formula by completing the square, which is a topic that we covered before. Let's start with the equation. I'm going to copy this equation. So this equation right here, ax squared plus bx plus c equals 0, is the general form of a quadratic equation because the highest degree is 2 and we have 3 coefficients a, b, c. And for many of you who know the quadratic formula, you know that the quadratic formula basically consists of these 3 coefficients. So to do completing a square, we're going to follow the step that we covered before. The first step is that we're going to make sure that this coefficient is 1. But right now it's not 1, right now it's a. So we have to divide everything by a in order to make the coefficient of x squared 1. So that's what I'm going to do. I'm going to divide the left hand side by a and divide the right hand side by a. So that will be the first inverse operation that we do for completing the square. Let's write down what happens after I divide everything by a. Ax squared divided by a, you get x squared. Next one is bx divided by a, so that's b over a times x. And then c divided by a, it's c over a equals 0 divided by a, still 0. Okay, so this is the equivalent quadratic equation, but the coefficient of x squared is 1, which means we're able to do completing the square. So completing the square requires you to move the constant term to the other side. And the constant term in this case is this one right here. So I want to move this to the right hand side. So we're going to do inverse operation, subtract c over a on both sides. Let's do that. And this will give me x squared plus b over ax on the left hand side. On the right hand side, 0 subtract c over a, it's negative. Sorry, it's negative c over a. Okay, and now we have this form and we're ready to do completing the square. So I'm gonna do a square first. So let's do a square first. All right, and I'm gonna cut the sides into 2 parts. So this is the structure that we did for completing the square. And then I'm going to write down the first term, x squared, which is right here on the top left. And that tells us that the 2 sides that we have for the first little square is x and x, right? Because x times x gives you x squared. And then the next term on the left-hand side is b over a times x. So it's multiplication. I'm going to divide it by 2 like we did before. So it will be b over 2ax. And then over here, b over 2ax. So what I did right here, I simply divided the second term, b over ax. I divided by 2, okay? And this is a rectangle. I basically split it into 2 smaller rectangles. If you wonder how you do the calculation, right here, I simply divide by 2, which is equivalent to multiplying by 1 over 2. And then you just multiply straight across. So on the top, it's b times 1, which is b. On the bottom, it's a times 2, that's 2a. And then you have your x. So that's how I got that, b over 2a times x. This tells us that the sides are b over 2a over here and b over 2a right here. And it's plus, it's positive. You could verify that. So if I multiply b over 2a by x, I got b over 2a times x. Okay. And now the most important number to complete the square will be this number right here. So this is another square. How do I know that? It's because the 2 sides, right? These 2 sides are these 2 numbers, and they're exactly the same. So to calculate this area, we simply do b over 2a times b over 2a, and that gives me b squared over 4a squared. So this is the number that we're going to add to both sides of the original equation so that we will complete the square. As you can see visually, we complete the square. Let's do this addition right here. I'm going to add b squared plus 4a squared on both sides. Okay, and this will give me the square on the left hand side. So on the left hand side, since we completed the square, I can write it as a perfect square. So just to look at this visual again, the big square has a side of x plus b over 2a. So I simply write it as a perfect square. X plus b over 2a squared. That's the left hand side. Equals the right hand side, I'm going to write as b squared over 4a squared, subtract c over a. And then I'm going to simplify the right hand side. So notice that the right hand side, we have 4a squared and a, these two denominators. The LCD is 4a squared. So I will write the second fraction right here. Do the transformation. Multiply both the top and the bottom by 4a so that the denominator becomes 4a squared as well, and then that will allow me to combine the right hand side. Let me write down the right hand side again. So x plus b over 2a squared equals, so over here the denominator is 4a squared for both of them, and then I'm going to combine the numerator. It will be b squared minus 4ac. 4ac comes from this part right here, c times 4a. Okay, the next step, after you complete the square, we apply the square root property. The square root property will require you to take a square root on both sides. So I'm going to take a square root on both sides. Just remember that when you get rid of the square on the left hand side, we have the plus minus, or you could put the absolute value. So on the left hand side, let me change the color. The square root and the square cancel out because they're inverse operations. We get x plus ba over 2a. But we don't know if this number that I just wrote is positive or negative. So usually we put absolute values around it. Or you could just put plus minus on the other side. And then on the other side, you take a square root of this fraction. And then you're going to split. So I'm going to split this. And then I think I'm going to write the work somewhere else. So for the right-hand side, you split the square root. On the top, it's square root of b squared minus 4ac. For the bottom, it's square root of 4 and square root of a squared, right? So I'm going to write them separately. Square root of 4, square root of a squared. So notice that on the top, you cannot split anymore because this b squared minus 4ac, it's not a product, it's a difference. So you have to put them together inside one radicals. But for the denominator, 4a squared, it's a product, which means we're able to split like I did right here. And let's keep simplifying this. On the top, we can't do anything, just copy that, b squared minus 4ac, the square root. And then for the bottom, you simplify each of them. Square root of 4 is 2, and square root of a squared is a. All right, now we can put this back to the original equation. So we have plus minus square root of b squared minus 4ac over 2a. Okay, and remember what is our job? Our job is to isolate x, solve for x. Our x is right here, so we need to get rid of this positive b over 2a. Performing inverse operation on both sides, subtract b over 2a on both sides. And then we get x equals, so on the right hand side, I'm going to put them together. Notice that they have the same denominator, right? You have 2a, you have 2a. So they have the same denominator, which means we can combine them. I'm going to put them as a single fraction. The denominator is 2a. For the numerator, I'm going to combine them. So the first term, I'm going to write it right here, negative b, right? And then plus minus, and then radical b squared minus 4ac. So let's put that. Negative b plus minus square root of b squared minus 4ac. And this is the quadratic formula. Okay, practice 1. The quantity b squared minus 4ac is called the discriminant. And the discriminant tells you a lot about the number and type of solutions to a quadratic equation. So let's look at all of the different cases. Start with the first case. When b squared minus 4ac, or the discriminant, is less than 0, we will get two solutions, and the type of solution will be complex solutions. So I want you to take a look at the quadratic formula and then think about why this is the case. So the first case, b squared minus 4ac is negative. Basically means that you have a square root, but the number inside is like a negative number. Like for example, negative 8. So you get a square root of negative 8. And then you have the plus minus some other number, right? So as you can see, this expression indicates that we have a complex number. And there are two of them because of the plus minus sign. As a result, we have two complex solutions. Case number 2, b squared minus 4ac is 0. If it's a 0, then this term becomes 0. So basically this goes away, including the plus minus. And as you can see, our solution is simply negative b over 2a. It's a real number, so we only have one solution, and it's a real and also rational solution. Rational just means that we don't have any radical signs. Okay, next one. B squared minus 4ac is greater than 0, and it's a perfect square. So again, it's talking about this radicand right here. This is positive, which means we don't have complex numbers. We're going to be having real solutions. And b squared minus 4ac is a perfect square, which means when you take a square root, you can completely get rid of the square root, so no radical signs. You're going to get two real rational solutions. Okay, last case. B squared minus 4ac is greater than 0, and it's not a perfect square. If it's not a perfect square, we cannot fully simplify this radical part in the quadratic formula. So we're going to have some radical left, but the number will still be real. So we will get two real irrational solutions this time. Irrational just means that we're going to have the radical sign. Okay, let's turn to page 2. Page 2, we're going to do 4 practices of quadratic equations. And today, our method is solving by quadratic formula. So let's put the formula on this page, right? It's right here. I'm going to make a copy. Let's see if I can do that. And right here. Paste. Okay, so I got my formula right here. And now we're ready to do these problems. You can do the same thing. You could copy the formula to the second page and complete the problems, especially the practice ones. So the example ones, I'm going to guide you through, but I want you to practice with the practice ones on your own. Starting with example 2. 3y squared minus 5y plus 2 equals 0. This is definitely a quadratic equation. The first thing I recommend that you do is that you're going to write down the ABCs. So matching this with the general form, What's the general form? You could go to the first page, take a look at the general form, which is right here. Ax squared plus bx plus c equals 0. So before you use the quadratic formula, make sure that your equation looks like this. And my equation definitely looks like that, right? The variable doesn't matter. You could do y, you could do z, but the format has to be ax squared plus bx plus c equals 0, which means you should have a 0 somewhere in your equation on the right-hand side by itself, or sometimes it's on the left-hand side. And the next thing you're going to do is you're going to write down the values of a, b, c. So a will be c, 3 in this case, and then b is -5, and then c is +2. Don't forget the negative sign for b. And then you could plug into the formula, or you could do something like I do. So what I like to do is I like to calculate this b squared minus 4ac before I plug them into the formula. It's just a personal preference. Let's calculate that. B squared, so that would be -5 squared, minus 4 times a, 3 times c, 2. And this you could enter into your calculator and get the result. So for this one, I will get 25 minus 24, which gives me 1, right? And we just did the categorization of different number and type of solutions. Our b squared minus 4ac is greater than 0, and it's a perfect square. So we're expecting to get two real rational solutions. Now let's plug these values into the quadratic formula. X squared equals, I usually do the denominator first. It's 2 times a. So what is our a? A is 3. 2 times a will be 6. And then on the top, negative b. B is -5. So negative b is +5. And then we have plus minus square root of b squared minus 4ac, which we calculated before, and it's 1. So I just put 1 here. And as you can see, there are benefits of calculating b squared minus 4ac first. If you calculate b squared minus 4ac first, your plugging process becomes much easier. Let's simplify this. So it's 5 plus minus square root of 1 is 1 over 6, right? And how do you do this plus minus sign, right? So you simply do the calculation twice. Let me write it somewhere else. The first one is 5 plus 1 over 6. That's the first solution. And the second one is 5 minus 1 over 6. And this is my recommendation to you. You simply write those two expressions separately and then calculate them separately. First one, 5 plus 1 is 6. 6 divided by 6 is 1. And second one, 5 minus 1 is 4. 4 divided by 6 is 2 over 3. So we got two solutions, as you can see. 1 and 2 over 3. Okay, I'd like you to practice with practice 2. Solve it and then check your answer. I'm going to give you the solution right here. Okay, example 3. Example 3, this equation is not in the general form, as you can see, because we don't see 0. We also don't see squares. So what you're going to do is you're going to distribute on the left-hand side, and then move the 5 to the left-hand side. So I'm going to distribute. I will get x squared plus 2x equals 5. Since we need that 0, I'm going to subtract 5 on both sides. And this will give me x squared plus 2x minus 5 equals 0. Now my equation is in the general form. I can write down the values of a, b, c. A is 1, b is 2, and c is -5. Just like before, I'm going to compute b squared minus 4ac. So that would be 2 squared minus 4 times 1 times -5. And you simplify this, it's 4 plus 20, and that's 24. My discriminant is positive, but not a perfect square, so we're expecting to get two irrational solutions. Let's put everything into the quadratic formula. Denominator 2 times a, our a is 1, so it will be 2. And then numerator, negative b, our b is 2, so it's negative 2. Plus minus square root of 24. Okay, so before I simplify this, I'm going to simplify square root of 24 somewhere, right? So let me put it right here. Square root of 24 is, you're going to split it. We have done this a lot of times. So it's going to be 4 and 6. And then square root of 4 is 2. So square root of 24 is 2 radical 6. Let's write that. Negative 2 plus minus 2 radical 6 over 2. And if you have radicals, you could do the same thing like we did before. Write down the two different expressions, simplify each of them. Or you could just do operations right here. This is because we're not able to combine these two numbers anyways, because one has radical, the other one doesn't. What I'm going to do is I'm going to divide the top by 2, right? So negative 2 divided by 2, negative 1. And then you have your plus minus. You could just copy that. 2 radical 6 divided by 2, it's 1 radical 6, which is the same as radical 6. So this will be the final answer that you can box. And as we expected, this is definitely two real irrational solutions. Okay, use practice 3 as a practice. I'm going to write down the solution. Example 4, 4x squared minus 2x plus 8 equals 0. So sometimes your equation is in the general form like this one, ax squared plus bx plus c, but you can actually simplify the equation a little bit. For this one, I noticed that there is a GCF, a common factor of 2 among all the coefficients. So I could actually take out this GCF and then rewrite the equation as 2 times 2x squared minus x plus 4 equals 0. So why do I take out the GCF? This is because I can next divide both sides by this GCF. And my resulting equation becomes 2x squared minus x plus 4 equals 0. Notice the difference between this new equation and the original. They're equivalent, but my new equation is much easier to solve with smaller coefficients. And that's actually recommended, so your problem solving becomes a little bit easier. Now let's write down our ABC. A is 2, B is negative 1, C is positive 4, and I'm going to calculate my B squared minus 4AC. B squared is negative 1 squared minus 4 times 2 times 4. So that's 1 minus 32, and that's negative 31. We got a negative discriminant. Based on our classification on page 1, we know that we're going to get two complex solutions. Let's plug them into the equation, quadratic formula. So x equals, denominator is 2 times a, which is 4. Negative b, that will be positive 1, plus minus square root of negative 31. Let's simplify square root of negative 31. So square root of negative 31 equals, we're going to split into square root of 31 times square root of negative 1. And 31 is a prime number, so we can't really do much about it. It's just going to be square root of 31i. And now let's put them back into the equation right here. So it will be 1 plus minus square root of 31i divided by 4. And that's our final solutions. We do have two complex solutions. Okay, let's use practice 4 as a practice. I'm going to write down the solution. Okay, the last example today. Solve 1 over 4 c squared minus 1 over 3c equals 1 over 12. This equation has a lot of fractions, which I don't like. So first thing to do is I'm going to find out LCD. The LCD here should be pretty easy to find. It's just 12. And then I'm going to do transformation, convert them to something over 12. 1 over 4, if I want to convert it to 12, I need to multiply both the top and the bottom by 3. 1 over 3, if I'm going to convert it to something over 12, I need to multiply both the top and the bottom by 4. And then 1 over 12, of course, I don't have to convert. Let's write down the resulting equation. So I will get 3 over 12 c squared minus 4 over 12 c equals 1 over 12. And now I converted everything to something over 12. I can cross out the denominator 12. Let's write down the resulting equation. 3c squared minus 4c equals 1. And of course, we're going to move that 1 to the left-hand side. So we have the general form of a quadratic equation. 3c squared minus 4c minus 1 equals 0. And now we have my ABC. Let's write them down. My A is 3, my B is negative 4, and my C is negative 1. Calculate the discriminant, B squared minus 4AC. That would be negative 4 squared minus 4 times 3 times negative 1. And that will be 16 plus 12. Which is 28. So this discriminant is positive, but not a perfect square. We're expecting 2 real irrational solutions. Let's put them into the quadratic formula. Denominator 2 times a, so that will be 6. Negative b, that will be 4. Plus minus square root of 28. Let's do square root of 20a here. So square root of 20a, we're going to split into square root of 4 and square root of 7, which simplifies to 2 radical 7. And now we can put it back to the quadratic formula. So it will be 4 plus minus 2 radical 7 over 6. And notice that there is a common factor of 2 between the top and the bottom. So I'm going to divide everything by 2 to simplify this fraction. So that will be 2 plus minus radical 7 over 3. And that will be our final solution. And again, there are 2 of them. We have 2 irrational solutions. All right, let's use practice 5 as a practice. I'm going to write down the final solution. Okay, thanks for watching.